Good day. As you can see, this is the electrolysis review. It really is more of a skim review. If you are struggling in this area, go back to the original notes so you get more details. So part one, lysis means to split. So electrolysis is splitting up a compound, and the compound would have been dissolved in a solution, but we're using electricity to zap it apart. Components of electrolytic cell are largely the same as electrochemical cell. We're going to have an anode, cathode, electrolyte, and external wire. The process is really a reverse or opposite of electrochemical cells, because now instead of taking a chemical reaction to make electricity, we're using electricity to make a reaction happen. So it says it's a non-spontaneous redox reaction. That means a reaction where if we have the chemicals together, nothing happens. But if we apply enough electricity, we can make that reaction happen. And that has some advantages. The big advantage is it means we can actually turn this reaction on and off. The disadvantage, of course, is we got to supply energy, and that energy in the form of electricity will cost money. So the characteristics of electrolytic cells are oxidation happens at the anode, and reduction happens at the cathode. So that's the same as electrochemical cell. One difference is the anode has a positive charge, and that will attract anions. The cathode has a negative charge, and that will attract cations. Now, there are different types of electrolytic cells, and type 1, of course, is going to be the simplest because all you have are electrodes, but they're inert, and you have a molten electrolyte. And whenever you see molten, it means we don't have water. So we don't have to look at our table of reduction potentials and worry about water reacting. So it means when we look at our electrolyte, we're going to have a positive ion, a cation, and all it can do is reduce. And it will reduce at the cathode. And we'll have a negative anion, and all it can do is oxidize at the anode. So there's only one possible oxidation, one possible reduction, and it's very easy to put together those things to determine the reaction. Type 2 is not quite as simple. It's the same as type 1, but instead of molten, now it's aqueous. And aqueous means dissolved in water. So it means that we have to worry about the positive ion, we've got to worry about the negative ion, but now we also have to worry about water, whether water will react before or after the different ions. So that's what makes it a little more complicated, but we have inert electrodes still, so we don't have to worry about them. Type 3, well, we go one step beyond type 2. We have our electrolyte. It's going to be aqueous. So that means we have to worry about our electrolyte itself. We've got to worry about water. And now we have to worry about the electrodes. Will the electrodes be what react? Because they're no longer inert. Number 6, we talked about 3 applications of electrolysis. Electrowinning, so that's a way of purifying a metal by pulling its ions from a solution. We have electro refining, and that's a way of taking a solid material that contains a mixture of metals, and we first oxidize it to put ions into solution, and then we reduce it to pull out only the metal ion that we want at the cathode. And electroplating, something you've done in the lab, is where we take our object that we want to coat, we make it the cathode by attaching to the negative terminal to attract the cations, and then we run some power for X amount of time, and all of a sudden the ions coat on that we want. So it could be gold, it could be chrome plated, whatever we choose. In the lab, we were doing some copper plating. The other thing we worry about with electrolytic cells is the overpotential effect, and what we worry about in this course is water. Overpotential means extra voltage. So in theory, where water should react, it doesn't, and it will react at a different voltage, and extra voltage has to be applied to make the water react, either oxidizing or reducing. And you see the overpotential effect on your chart for water being reduced on the left and oxidized on the right. So that's a very short review of electrolytic cells. If it's not all making sense, go back to your original electrolysis notes along with making corrections to the electrolysis questions.